Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 28 on using the Arduino microcontroller. So I need you to pour yourself a big cup of coffee, sit back and get ready to learn how to program software interrupts on the Arduino. I'm really excited about this lesson because this will allow you to take your Arduino projects up to that next level. Now let me explain a little bit about what we are trying to do here and what we really mean by a software interrupt. Okay, so let me get a couple of things called up here real quickly. All right, so this is a very simple program. You can see that I have my Arduino microcontroller programmed up to blink a red LED. Okay, I am just simply blinking a red LED, and the code for that is very simple. We simply come in and digital write the red LED pin high. We wait for 1,000 milliseconds, and then we digital write the red LED pin low. And so we turn on, pause a second, turn off, pause a second, and then loop back on, pause, off, pause. And therefore we get the old program, probably one of the first programs you ever wrote to blink an LED. Very simple. Okay, now I'm going to tell you something. The next step up, which sounds like it would be real simple, but turns out to be incredibly hard on something like the Arduino. Let's say that I wanted to blink the red LED on a second, off a second, and at the same time be blinking the yellow LED, let's say, on for a quarter of a second, off for a quarter of a second. So blink the yellow LED independently and blink it faster. Well, it turns out that that is really a very hard thing to do, because what you have to understand is that the Arduino does one line of code at a time and then goes to the next one and then goes to the next one. So we right here turn the red LED on, and then right here we are delaying for 1,000. The thing to understand is the program stays at this step until that 1,000 milliseconds is up, and then it goes to the next step. So while I am sitting here waiting, I can't be over there turning the yellow LED on and off. So even though it sounds like a very simple thing, it turns out to be something that the Arduino isn't really well suited for, because the Arduino, as a simple microcontroller, has one program running at a time and has one main loop going. So it's not like Python, where you can have multiple programs running at once or multiple threads running at once. And so what we need to do is we need to introduce the concept of an interrupt, a software interrupt. And what a software interrupt is it's something that runs in the background. It's a little part of the Arduino running in the background. And as your normal main loop is executing this step, this step, this step, this step, there is something called an interrupt that's programmed, and on a certain event or at a certain time, wherever you are and whatever you're doing, it will stop, run over and do this other step, and then come back. So it's an interrupt where you interrupt your normal program flow, come over, do something else, and then come back. Okay. Now there are two types of interrupts. There are hardware interrupts, where that interrupt happens based on something happening on a pin, like a certain pin goes high or a certain pin goes low. You see something happening on the pin, you run off and do the interrupt. We will do that in a future lesson. Today the interrupt that we're doing is a software interrupt, and that is I want to every so often, every certain period of time, run off and do something. So it's like a separate timer running, that when the timer comes up, runs off, does something else, comes back, and then continues the normal program flow. So today we're going to learn software interrupts. Next lesson we'll probably do more advanced software interrupts. Then we're going to do hardware interrupts, and then I'll show you some of the more complicated things you can do with it. Now, one of the things I said is that I'm illustrating this with this simple blinking the LED program because it's easy to understand, but really some really important things would require interrupts. Sometimes when we're working with multiple sensors with the Arduino, if you have something like a GPS, a lot of times the GPS is just spitting out serial data. And if you're over here working on something else and that GPS piles up a bunch of data, you're going to overflow your buffer. You're going to be reading old, stale, corrupt, incomplete data from the serial port. So you need to have something like an interrupt so that every little bit you can run out and get the data off of the off the serial port. So there's a lot of really important functions to do with it. So let's jump right in and start working on this. First of all, if you want to build this circuit that we'll be doing the demonstration on, you can come here, and this is a picture of it. We have a yellow LED. The yellow LED is tied through a current limit resistor to pin 10. The red LED through a current limit resistor to pin 9. The current limit resistor can be between 200 and 500 ohms. It doesn't really matter. Okay, this is the circuit we can use. Also, go to the link in the description below, and it'll take you to the toptechboy.com lesson where we have the code and the links and all that sort of stuff. So you can just go to the description of this video, click on the Top Tech Boy link, and it'll take you to this lesson on the Most Excellent website. Okay, so you're going to want to build this circuit. Now, the thing about the Arduino interrupt is, as configured, it will not do these software interrupts. So you need a special library to do these interrupts. And down at the link, toptechboy.com, in the description that links to my lesson on my website, you can just click to get to this page. But if you want to do it the old-fashioned way, you can see the URL is https://code.google.com/archive/p/arduino-timer1/downloads. And then you will come to this page, and then on this page you will want to go to zip. Okay, it's the timer1-r11.zip. timer1-r11.zip, and if you click on that, it will download that zip file down here in the bottom of your browser. You will be able to see that. You can click on it to open it, and then this is the library that allows you to do an interrupt. Maybe not everyone has installed a library before, so I'll go a little bit slow here. Sorry for you experts, but I just never want to leave anyone behind in the dust. So let me show you how you can get to the Arduino library. Okay, so what you want to do is you want to open your Arduino program, okay, as such, and then you want to come under File and look at Preferences, and then right here under Sketchbook Location, that shows you where you can find the library folder. I like to just select it, Control C, and I've copied it. Then that's all I need. I can close that, and then I come back over here to my folder, and then I can just click here on my folder and Control V. It will paste that location in, then enter, and boom, I am in my sketchbook folder. Okay, if you guys are experts, you know how to do this, but sometimes people get lost in trying to find this. All right, so now I am in the Arduino folder, my Arduino folder. Yours might be somewhere else, but if you do what I just said, that'll help you find it. And then you look in libraries, and ooh, you can see that I already have that, so I'm going to delete it so I can show you how to install it. Yeah, all right. So now here you want to create a new folder. So I create new folder, and again, I'm in the Arduino libraries, and I want to call this Timer 1. Okay, Timer 1. Now what I want to do is go back to, we are going to go back to where we had downloaded this. It looks like I need to maybe click on it again. Okay, so we're going to click on timer1-r11 zip. Okay, it comes down here. We're going to open it, and there we have it. And now we come back to the folder that has the timer 1. We select all this and we drop it in timer 1. Okay, so I have Arduino libraries, I have my timer 1 folder, I open timer 1, and there is the library. Okay, so that looks good. So now we're going to see how do we write this code that would allow us to simultaneously blink the two LEDs. And so let's come over here and get started. Okay, so I will just start with a new empty sketch. Okay, I will make that full screen. I think you can see that. First thing I want to do is I want to make sure that I got that library in there correctly. And so to load the library, you put hash and then include and then open bracket timer 1.h and then close bracket. And I'm just going to download this and see if I can do it without getting an error. And I just want to make sure that we got that library installed correctly. So I download it. It wants to save the program. Okay, save it, not a problem. Okay, and it looks like it is compiling, and it looks like it downloaded without a problem. So what does that tell me? That tells us that we have correctly installed the timer interrupt library. Okay, now we need to do some stuff. We're going to start writing the code now, so we're going to need some variables. One thing is, if we are going to be turning this LED, this second LED on and off with an interrupt, we got to keep track of whether the LED is on or off. And so I'm going to put string LED status, and then I'm just going to initialize it, just say initially we haven't turned it on, so it is off. All right, and so this is just a little variable LED status that's going to keep track of whether our yellow LED is on or off. Okay, now we are blinking two LEDs, so we're going to need to give variable names for their pins, and so we're going to have yellow LED, and that's going to be equal to 10. Okay, and then int red LED is going to be equal to 9. All right, and that's just saying I'm hooking yellow LED to pin 10 and red LED to pin 9. And then I think that's all the variables we need. We need to do always do our void setup. So we're going to come here and we're going to do our pin mode. Yellow LED is going to be an output. Okay, pin mode red LED is going to be an output. Okay, and then now is when we actually get to the real business. This is where we are going to define our interrupt. Okay, and so we're going to start our interrupt. So I'm going to say timer 1, right? We included timer 1 up here. Okay, but the actual command is timer 1, the number 1. Okay, timer 1 dot initialize. Okay, now this is how long do you want to run before you set off the interrupt. Maybe you would want to run for a second, maybe 10 seconds, maybe a maybe 1/100th of a second. I don't know. Why don't we set it at a second, okay? And the units are in microseconds. So if I want 1 second, I would need to put in a million. So 1, 2, 3, 1, 2, 3, 6 zeros. Okay, that's a million microseconds. So what I'm saying is I'm starting, it's like setting an alarm clock. I'm starting an interrupt, and that interrupt is going to go off once a second. So it's kind of like this is going to be running, and once a second he's going to say, over here, once a second, over here. So no matter where your main code is, this alarm is going to go off once a second. Okay. Now we've got to tell it when the alarm goes off, what do you want to do? Well, what I would like to do is I would like to run a program called blink yellow. So I'm going to say timer 1 dot attach interrupt. Okay, and if you do it right, you see how it changes color. So this is every second when the interrupt goes off, what do you want to do? Well, I want to do a function called blink yellow. All right. So what have we done here? Once a second, an alarm's going to go off. When that alarm goes off, it is going to run down and do blink yellow. All right. And notice attach interrupt, the I is uppercase, and you've got to spell it just right. And if you spelled it right and you included the library, it should turn a color. So if I'm going to call this function blink yellow, I better define it. So I'm going to come down after the void loop, and I'm going to define this. And so what I will do is I will say void, which means this is a function, and I'm going to define void blink yellow. Got to type it exactly like before, but then I got to give it the open and the close, the old open close, and now begins curly bracket. Okay, now so then let's make sure this is that's opened and closed, and then the void blink yellow is open and closed, and the void loop is open and closed. Got to keep your curly brackets you got to keep your curly brackets straight. So let's see, that would be the this would be in between here, between the open and the closed curly, will be what is executed when blink yellow is called. So I think we're ready to go. So I'm going to say if, and then if LED status equals on. Okay, in other words, if the LED is presently on, what do I want to do? Well, I want to turn it off. So to begin the if statement, open curly, come down. So if the if the yellow LED is already on, what do I want to do? Well, I want to digital write. What do I want to digital write? Yellow LED. And what do I want to digital write it? Okay, I want to write it low. Why? Because if it's on, I want to turn it off. Okay. And then if I'm going to turn it off, I better adjust the LED status so it remembers that it is now what? Off. Okay. So let's think about this. We come down every 1 second, the alarm goes off, it calls blink yellow, and then it comes down here to void blink yellow. And if the LED was already on, what do we want to do? We got to turn it off, and then we've got to update our status to remember that it's off. I think that looks really good. And then at that point we can return, and that just means leave this function. All right, what's the other possibility? Well, if LED status equals off, okay, open curly, come down, digital write yellow LED high. Okay, and I forgot up here, this if statement has an open curly. I need to put the close curly, and then this one has an open curly, so I need to put a close curly. I hope I'm keeping up with these right. I feel like I've got an extra one here somewhere. I think I do. Okay, so let's see. This one closes the void loop. This one closes that if statement. This one closes that if statement. And I think I still have an extra one. Okay, so if LED status equals off, and I got to close that. I am making all kinds of mistakes. Right. If LED status equals off, if it's off, what do we want to do? Digital write yellow LED high. We want to turn it on. And then now that it's on, we've got to adjust LED status, and we got to say that that equals on. So we always keep track of where we are. I am afraid to even download this thing because I think I'm going to get errors. I'm just going to see if this is going to, yeah, what did I do? Red LED, oh, pin mode. I didn't type pin mode right. Okay. You guys were probably yelling at me when I did that. Okay, timer 1, blink yellow. Timer 1 was not declared. Timer 1 with a capital T. So you guys probably saw this as you were going through. Okay, it looks like it's compiling now, and so that is looking good. So I just want to make sure that I kind of got the errors cleaned out before we go on. So now what do I want to do in the void loop? I'm going to just do the good old-fashioned blink the red LED. So what are we going to do? Digital write red LED, and we're going to go high. Okay. And then what are we going to do? Delay. So let's say up here we are blinking the yellow every second using the interrupt. Well, let's blink the red every quarter second. So we'll say delay, and we'll say 250 milliseconds, which would be a quarter of a second. Then digital write red LED low. Okay. And then delay 250. Okay, so let's review what this program is going to do. The main loop is going to sit there, turn the LED on, wait a quarter second, turn the red LED off, wait a quarter second, turn the red LED on, wait a quarter second, turn the red LED off, wait a quarter second. But while that's doing that, up here we have this timer that is running, and every second, every 1,000 or every million microseconds, no matter where the program is, this timer is going to raise an alarm, and doesn't matter where you are, it's going to leave, and it's going to do what? Blink yellow LED. What does blink yellow LED do? Well, if the yellow LED is off, it's going to what? Turn it on. If the yellow LED is on, what's it going to do? Turn it off. Okay, so these two kind of simultaneous things should make them both blink. So let's download this and see what happens. Okay, let's look here. All right, look at that. Boom! We programmed an interrupt. The red LED is on, off, on, off, and that is based on this, okay? Turn the red on, turn the red off, turn the red on, turn the red off. But besides that, the yellow one is blinking on a second, off a second, on a second, off a second, on a second, off a second. Okay? And that, my friend, is because of the interrupt. All right, that's because of the interrupt. All right, let's try something different. Let's say that we wanted to blink it the other way. So here we're going to put 250,000 microseconds. That's a quarter of a second. 250,000 microseconds is going to be the interrupt rate. And then we're going to come down here and we're going to delay 1,000. Okay. And 1,000. Okay, so now let's download that. Okay, come back over here. Boom! Look at that. The red LED on a second, off a second. On a second, off a second. While the yellow is going 4 times as fast, okay? So do you see that we can have these interrupts to do some really, really important things? Really important things. And you can see that this interrupt down here is just done really quickly, so it doesn't really impact the timing. Okay, so if you write these things right, it doesn't really impact the timing of the main loop. Okay guys, this is how you do a software interrupt. I'm hoping that with this simple example, this would allow you to then go away and do the more sophisticated things you would want with like a GPS. Where I really find that I need interrupts. One is with something like a GPS where it is cramming data at me, and if I don't have an interrupt to go over and start pulling that data off the serial port, I can end up in trouble. And also there's some things like a directional cosine matrix which has to be run continuously, and if you get off and ignore that, then it can crash on you. And so an interrupt is a very powerful tool that you can use, and I hope that this example shows you how you can use it. I hope this will allow you to begin to take your Arduino programs up to that next level. Okay, guys, I hope you've enjoyed this lesson. If you have, think about giving us a thumbs up. Think about sharing it. Maybe subscribing to this channel. Love to hear your comments down below. Let me know what you're thinking. Let me know if this has worked for you, or if you, let me know the places that you're using interrupts, or what particular interrupt problems you're trying to solve. Okay, Paul McWhorter from TopTechBoy.com. I will talk to you guys later.